Hi everyone, this is Adam again. So in this video, I'm going to cover length, area, and volume. Okay, so just of different shapes and stuff like that. Okay, so first of all, for a rectangle or a square, it's just length by width. So area is just L times W. That's all. Okay, so just this length multiplied by that length. That's all. Okay. The perimeter is kind of if you walked along the outside, how long would it take you to go around? So in this case, the perimeter is going to be L plus W plus L plus W. So it's just 2L plus 2W. Okay, so that's all you need to know. So the perimeter is just how long, if you were to walk around it, would it take? How long would you have to walk? Okay. Then for a triangle, so the area of a triangle, where this is the base, B, and this is the perpendicular height, H, the area, A, is equal to a half the base times the height. And this would be the same thing if it was something like this, where that was the base and then this was the perpendicular height. Okay? So it's very important that you should remember that it's the perpendicular height you're working with the whole time. Okay? And then for a parallelogram is kind of very similar, just there's no half. Because again, a parallelogram can be seen as two triangles, where this is the base, that's the base, that's the perpendicular height H, and then this is the same height over here, H. So the area of a parallelogram is just the base times the perpendicular height. Okay, and the same for a rhombus. Okay, the last one then is a trapezium. So a trapezium is just when you have two lines that are parallel like this, and they're just joined together. So again, if you have the perpendicular height here as being H again, if this is length A and this is the length B, then the area is simply, it's A plus B over 2 times H. So it's just an average of A and B. That's all. Okay? So hopefully that's all okay. Now, the most important one of these is circles. Okay? So, the circumference of a circle is this length. So how long does it take to go all the way around? So the circumference and the perimeter are the same thing of a circle. And then the area is just this. Okay, so the perimeter or circumference is equal to 2 pi r, where r is the radius. So remember, in a circle, this is the radius, and then this would be the diameter. Okay? So it's also equal to pi times the diameter. All right? And then the area is just equal to pi r squared, like that. So not too bad. Now, the most important one then, or, a very important thing to know. So again, so all these formulas are in your log tables, so there's no need to turn off any of these. Now, the next formula, technically, yes, it is in your log tables. Will you recognize it if you see it? No. So this is a very important one that, so yes, you do, it is in the log tables, but you kind of have to know it off the top of your head, to be quite honest, because it's one of those things of in an exam you won't really figure it out. Okay, So in this one, it's when you work with sectors of a circle. So what's a sector? A sector is something like this, where you have this thing. This is an angle theta. And this is like a sector of a bigger circle. So it's just kind of like a section out of a bigger circle. So if they ask you what this length was, the length is simply equal to, where again, this is the radius, it's just 2 pi r multiplied by theta over 360. Okay? So what you're saying is, you're saying that it's the full circumference. So again, 2 pi r is just the full circumference, multiplied by how much of the circle do you have. So in this is kind of like how much do you have? So again, if you had like 180 of theta, then that basically means you have 180 out of 360, which is half. So 180 degrees in a sector is just half a circle, and therefore your circumference is half as long. Okay? So you also have the area. The area is quite literally the exact same thing. It's just pi r squared multiplied by theta over 360. So again, it's just this idea of, this is like how much of the circle you have, and obviously the area, if you cut a bit out, is just how much have you cut out, basically. Okay? So hopefully that's all okay. That's just to say that if you have something like this, where this is 6 centimeters and this is 84 degrees, how would you figure it out? You would say, okay, so first of all, the area is pi r squared, which is pi times 6 squared, multiplied by 84 out of 360. And then the length L, so again, this length here, is going to be 2 pi times r, which is 6, multiplied by 84 over 360. Like that, okay? So hopefully that's all okay. And then if they ask you for the circumference, that would be L plus 6 plus 6. So again, the circumference is this length plus that length plus that length. Okay? All right. So that is that. Then if we go on to nets, so I'll do that next. So now this is just, again, this is now working on volume. So we're working on area and circumference and length there. So now we're going to look at volumes instead. So a volume of something like a cuboid. So a cuboid would look something like this. So you would say this is the length, this is the breadth, and then this is the height. You could also call this the width if you wanted to. So whichever one you want. But the volume is simply L multiplied by B multiplied by H. Or L multiplied by W multiplied by H. So just multiply the three lengths together and then off you go. Okay? So now this thing here, this is called an edge. This here is called a vertex or a corner. And then this thing here, that's called a face. Okay, so they might just ask you in a question, say, how many faces does this shape have? In this case, you would say 6. Because you have a front, you have a back, you'd have a right, you have a left, you have a top, and you have a bottom. Okay? So that is kind of all that's important there. Now you also have the volume of kind of weird shapes. So something like this. If they ask you to calculate this volume, the way you do this is you would calculate the area of this thing. and then you would multiply it by this length down here. Okay, so volume is also equal to area times length. Okay, so I'll give a concrete example of this in a second when it comes to cylinders, but it's just if you have any sort of a weird shape like this, if this is 10 meters squared for the area, and then you're told that it's 5 meters high, then the volume is just 10 times 5, which is 50. Okay? So that's all. That's the only thing to note with one of those. Okay? Now, moving on to cylinders, cones, and spheres. The volume of a cylinder. So a cylinder looks like this. Where this is the radius of the circle and this is the height h. So again, the volume is just going to be the area of this thing, which is pi r squared, multiplied by the height, which is h. Okay, so that's it. If you were to kind of spread this out into its net, you would get something that looks like this. So this would be the top, that's the bottom, and then this is kind of your rectangle, or like your curved surface area. Okay, so your curved surface area is equal to 2, because this length here is 2 pi r. And again, this is just the height h. Now that might seem weird, that kind of this part of the cylinder, so the kind of curved bit out here, that would be that would look like a rectangle. The best way to imagine it is, imagine if you had some sort of roller like this, and you were going to paint your wall with it. If you press that up against your wall and you went up and down like this, what sort of shape would you expect to get? You'd expect to get some sort of rectangle like this. So that's where this rectangle comes from, and that's why it's a rectangle. Okay, this is where I'm going to say as well, there is another thing is like surface area, which is just, if you had to paint this object, how much paint would you need? You need to paint the top, you need to paint the bottom, and you need to paint this bit out here as well. Now, they might ask you, okay, what is the surface area? The surface area is equal to the area of this thing, which is 2 pi RH, plus the area of the top thing is pi r squared, and the area of the bottom is also pi r squared. Okay, so the total surface area is that. Now be careful, because the curved surface area is only equal to 2 pi RH. Why? Because the top and the bottom are both flat. They're not curved. Okay, the only thing that's curved is this bit here. Okay, so obviously you can see that it's curved up over here. Okay, so that's one thing and to be careful of, because in the log tables it only gives you the curved surface area. So it will tell you that the curved surface area of a cylinder is this. It won't give you this up here. So if you're asked for the surface area in an exam, they're looking for this, okay, with the top and the bottom included. Okay, that's a cylinder. And then for a cone, so a cone will look something like this. Where this is your height h, and then this is your radius r. So the volume of a cone is 1/3 pi r squared h. Okay, so again, the curved surface area of this thing is this part, and the total surface area would include the bottom circle. Okay, so just to be careful with that. Another important thing is that your curved surface area is equal to pi RL, and your total surface area is equal to pi RL plus pi R squared. So L is this length here. And if you use Pythagoras' theorem, I'm assuming you know this from junior cert. If not, I'll also have made videos about Pythagoras' theorem for paper 2, not paper 1. But basically you have that L squared is equal to H squared plus R squared, and therefore L is just the square root of H squared plus R squared. So that's what L is up here. Okay? Okay, and finally, a sphere. So a sphere is the most important shape out of all of them. To be able to, it's the most common one that comes up. So for a sphere, what you get is you have this. You kind of have a little sphere around here, where this radius is R. So first of all, the volume is equal to 4/3 pi R cubed. And the surface area, so again, the surface area is equal to the curved surface area this time. And it's equal to 4 pi R squared. Okay? Now, if you have a hemisphere, so a hemisphere would look something like this. A hemisphere is just half a sphere. It's basically if you just grabbed it and cut it in half, what would you be left with? The volume of a hemisphere is just 2/3 pi R squared. The surface area is equal to 2 pi R squared. So again, it's just half of the surface area up here plus pi R squared. Why? Because you also have this face here. Okay? But the curved surface area is only equal to 2 pi R squared. Okay? So just to be careful of that. All right? Now, one very important one that comes up is basically you have so this is the thing that it comes up in junior cert, it comes up in leaving cert, and loads of people struggle with it. It's basically you have a ball and that you don't know what the radius is, and you have a cylinder like this that has some amount of water in it, or some amount of liquid, doesn't really matter, but just say it's water for the argument, okay? And what happens is that you drop the ball into the cylinder. And what happens now is that the ball is now down here, and you have seen an increase in volume. They tell you that the increase in height, h, is equal to 4 centimeters. And they also tell you that the radius of the cylinder is equal to 5. Okay? They want to know how big is the ball. So, what you need to understand is that what did you do? So you have this initially, that's fine. Then something happened. What happened? You put the sphere into the cylinder, it went into the water, and now you've seen an increase, this increase, specifically due to the sphere. So what that means is that the increase in volume that you observe must be the volume of the sphere, because what did you do to the water? You added the sphere, and you've seen, I've seen the water level rise by this amount. That means that the volume, so the increase in volume, has to be equal to the volume of the sphere. Okay? So hopefully that makes sense. So now that's what I'm going to do. Now remember, this thing here, if I just grab this and move it down here, what am I left with? I'm left with a miniature cylinder, where this has a height h, which in this case you're told it's 4, and it has a radius of 5. How does it have a radius of 5? Because the cylinder has a radius of 5, and therefore this cylinder will also have a radius of 5. So now, the volume of a cylinder is pi r squared h, and that's equal to the volume of the sphere, which is 4 over 3 pi r cubed. So first things first, I can get rid of the pi on both sides. Okay? So r squared, that's going to be 5 squared, which is 25, times h, which is 4, so it's 100, is equal to 4 over 3 r cubed. So divide both sides by 4, I get 25 equals a third r cubed. Multiply both sides by 3, I get r cubed is equal to 75. So r is going to be the cube root of 75. So r is going to be equal to 4.2172 centimeters. So that's how big the ball is. Okay, so the main thing to know is that just this is when you go from this state to this state, what happened? You added the cylinder, you observed that there was an increase in volume, therefore the increase in volume must be equal to the cylinder, sorry, the sphere, because the sphere was the thing that was added. Okay. All right, hopefully that's all okay. There's one more thing that I want to do in this section before we go over to the approximations. But basically, you also have something like a cone like this. Okay, so you have a cone like this. You have a height here, so this you're told is 20. This is 10. And you're told that you're after cutting a top off this cone. So you just come in and you've chopped off the top of the cone, and this is 1.5 centimeters. Okay. First of all, what they want to know is what is the volume of this shape that's left. So the volume that's left would be the volume of the big cone minus the volume of the little cone. So that's the easiest way to do these things, because you have a weird shape. You can't get the volume of this shape on its own. But what you can do is you can say, well, what's the volume of the big cone? I can figure that out. What's the volume of the little cone? I can figure that out. What did you do? You got the big cone, you got rid of the little cone, and that's what you're left with. So that's what I'm trying to figure out. So first of all, what's the volume of the big cone? So what's the total cone? So the volume of a cone is 1/3 pi r squared h. Okay, so first of all, the big cone is 1/3 pi times r squared. R squared in this case is 10. And the height is 20. Now, I don't know what number is squared, but I know that the height is 1.5 of my little cone. So what I need to do is I need to figure out what is the radius of the little cone. Now, this is a very important concept. In the same way that up here, the shape of the cylinder stayed the same from there to there. The only difference is that the height changed. The same thing is true here. The shape of the cone stays the same. Okay? So in the big cone, you have that the height is 20 and the radius is 10. What does that mean? That means that the radius is half the height. So that's also true for this. So for the little cone, the radius must also be half the height. The height is 1.5, and therefore the radius is 0.75 centimeters. Okay. So that's the biggest takeaway from this. It's just that the shape of the cone will stay the same if you cut little bits off. There's no reason for it to change, and therefore it doesn't. Okay. So in here we'll go 0.75. And so the volume is just equal to whatever that comes out to be. So just plug that into your calculator one at a time, and then that'll it'll turn out to be whatever it is. Okay. So hopefully that's all grand. There's one more thing that I want to do before I leave this chapter, and move on to indices and logarithms. But what it is, it's the trapezoidal rule. Okay. So the trapezoidal rule basically says that if you have some sort of weird shape and you want to know what's the area of it. So if I asked you to figure out what the area of this shape is, the idea is that you haven't a notion what the area of that is. But what you can do is you can put little gaps here where all of these have a length h. And you can make trapezoids out of these. Okay? Because I know how to get the area of a trapezoid. So a trapezoid is this shape here, from there to there to there to there. Okay? So that's all you're doing. It's just this and this and this and this and this and this. So you just make a load of trapezoids out of it. Where this is the first height, y1. This is the second height, y2. You keep going all up to yn and yn minus 1. So this is basically just, you say that there's n of them. So obviously the smaller h's, the more little sections you're going to have. Okay? So what is the area? The area is h over 2 into the first height plus the last height plus 2 times all the heights in between. Sorry, that should be an n. Sorry, I didn't mean to put the second height. I meant to put the last height, so n. Plus y2 plus y3 all the way up to yn minus 1. And that's it. That's all you do. Okay? Alright, so I'll do a little example now. The little example is something that looks kind of like this, okay? So here, what you have is, you have that your horizontal lengths are 3, and your vertical lengths are going to be 3, 2, 2, x, and 2. So again, all of these down here are 3. And they say that the approximate area is roughly equal to 40. Figure out what x is. So in this case, you would say, okay, 40 is equal to h over 2. What are these lengths? They're 3. So it's 3 over 2 into, what's the first height? The first height is 0. What's the last height? The last height is also 0. Now, how do you tell this if is it the first height or the last height? The first height is always what's the left-hand height of the very first section, and the last one is always what's the right-hand height of the very last section. The height of this section here on the left is 0, and the height of this section on the right is also 0. That's where I got these two numbers from. Plus 2 times all the numbers in between. So it's 3 plus 2 plus 2 plus x plus 2. Okay? So I get 40 is equal to, that 2 and that 2 cancel. So it's 3 times 3 plus 2 plus 2 plus 2. That's equal to 9. Plus x like that. Okay? So I can divide both sides by 3 and say 9 plus x is going to be 40 over 3. So x is going to be 40 over 3 minus 9, which is 40 over 3 minus 27 over 3. So x is going to be 13 over 3 units. Okay? So yeah, that's everything with that chapter. So that's how you use the trapezoidal rule. And they might say the actual area is maybe 39 units squared. What's your error? So your percentage error in this case is always the error, which is 1, divided by the actual, which is 39, and then you multiply that by 100/1 to make it a percentage. Okay, so that's how you do that, where 39 is the actual value. Okay, so hopefully that's all right. I think I'm going to leave that because that was quite a long video. So I think that's enough for today. Okay, so thank you very much for listening, and I think I'll leave it at that. I'll see you in the next video.